All right, everyone. Sorry for that delay. Let's see. Everyone that's here, go ahead and say here. All right. Little lacking. Hopefully everybody is watching the VODs, the VODs. I'm trying a full screen setup today so that we can hop back and forth between. Looks to be working fine. But that way we can hop back and forth between the code and web pages. One second. Sorry about that. Didn't want to display all of my desktops. So let's go ahead and talk about the example from last week. We were going through, and even as I was programming, I knew something was wrong, but I couldn't figure it out. It was a really interesting happenstance based on my experience with other programming languages. So I was making a mistake of assuming that these would work. Now, can anybody tell me why these won't work? As soon as class ended, it took me like 3 seconds to realize. And I told you it was one of those situations where a snake bite would have killed me from it. But does anybody have any ideas why this doesn't work? All right, let's reorder things like this. Sorry about that. Had a weird Are you guys still there? Are you all still there? Okay. Sorry. My system just acted like I had monitors plugged in and out, and it was weird. Sorry about that. So we'll add these final. Well, final doesn't matter. But what we're doing is the difference is here. This is setting it statically. It's trying to call upon the repo when this class is pulled into the class loader. So that's the distinction between static and non-static. So this is a static call to repo, and repo would be getting like this. These would work fine, and that's what we saw last time. Okay, so what we had last time is this worked because it got an instance of MVVM repo when the class was loaded into the class loader. But when we went like this, which is what we want, even if this will work, but this here is going to cause a null pointer exception because repo, before we instantiate this object, repo was trying to be accessed, and it's a null. Does that make sense? It's perfectly logical, but it's a nuance between Java and Kotlin. Kotlin, by default, the things in here are non-static, like methods like this. They're part of the object, whereas in Java they're static. So, if they're initialized statically. We'll put it that way. I'll have to get a much better definition for distinction on that for you, because this is a static definition of it, but the variable isn't static. It's a little nuancey difference there, but I just wanted to explain to you, don't do the assignments inside the class like this unless they're constants. So if you're going to do something like this, that would be fine. But don't call upon other objects that might be null. Does that make sense to everybody? So let's first recap what we're looking at. I'm showing you a simple example of what's called the MVVM. Model, view model pattern. And it's a architectural design pattern that you use to define how these classes are going to interact with each other. Often you have a repository for improving testability. We'll get to that here in a little bit. But you have a view, and in the view, it has a view model. That's the view model. We can do this. if you design it well, you will pass in the repository so that you can test where it gets its strings from, and then the logic is in the view model. So does that make sense? You have a view here. So a view is a UI widget. We'll put it that way, like button or text views where you put text, or edit text view is something on Android that you can click and put in information. Not very original names, but you don't want originality when it comes to core features. You just want them being straightforward. So you have your view here, and it has text, and it has a text color. So let's pretend we're making a text view. And public void button press. Let's pretend there's a button in this view, and when it is clicked, this method gets called, just for sake of argument. What would you do in this case? You would pass that logic to the view model, and I'll explain why here in a second. Well, button press doesn't exist, so come over here. All right. So this is a complicated example, and so I want to work our way through it. So we have a view here that we're putting up on the screen. We're pretending that there's a button on it. It has some text and some color to the text. We click the button. Why would we pass the button press to the view model? You might be wondering. And honestly, it's a really good question. The real reason is so that you can locate all the logic inside the view model, and you'll notice view model doesn't extend anything here. Well, in Android, for custom views, that isn't true. They have to extend a view type. Or here, they have to extend a view type. And in view model, they don't have to do that. So why is not extending anything important for the view model? Because that makes it easier to test. And since we're passing in the repo, it makes it easier to test also because we can control in our unit tests what the repository is going to return when the class being tested asks for view text color. We can give it like the hex code for red or the hex code for blue. And we can ask get text color. And if the text color doesn't match what we told the repository to return, we know somewhere in this code here in this class, there's a logic error. Does that make sense so far about the basic idea of how these classes interact? I'm going to actually go ahead. This is purposely not an Android example, but when we get to an Android example, it's going to be almost one-for-one for this. I just wanted to keep it a little simpler and not have what's called a context to deal with and all this other stuff, but all the Android-y stuff, basically. I didn't want to have that cluttering the discussion. But is everybody following along so far with this idea so far? If I'm guessing not, so it's fine if you're not. We just want to hammer home this concept of testing and why you test. You don't get or passing a repository as an argument. Okay. So, let's take a step back. If you don't pass a repository as an argument, let's come back here to the view model. Then you have to instantiate, let's just do it here, repo equals and repo dot get instance. This will work perfectly fine. But let's even make this final. Oh, integer. Whatever. It doesn't matter. We'll just say 225. That's not at all a real number for colors. But let's just pretend it is for now. All right. So if we don't pass in the repository, excuse me. And let's, you know what? Let's actually do that. Let us test this method. So to get this pop up in IntelliJ, it's Alt Insert, and it gives you a list of things you can do, and test is one of them. So let's go ahead and test these 3 buttons, and we'll even do a setup and tear down. So before each and after each, these are special methods. We'll get to them in a second. But here's our tests. Okay. This is just always going to fail. Oh, and here's a nice little trick. I never knew this. You can press this and it'll take you to the class. Whatever class you're in, you can press here and it'll take you to it. So it stops you from having to go down through this entire list of things. Pretty nice, actually. Always learning new things. So here's our view model test. Let's run this. Most of the first two tests are going to succeed because there's no failure state in these. And the third one is going to fail. Oh. Don't need that. Okay. That's fine. Let's run the test again. We changed so exactly what I was said. Come down here to the test. First 2 pass. And the third one, button press fails. That makes sense to everybody, right? Because I said assert false and I gave it a true. So it's just going to fail. We delete this. We run the tests again. And they're all going to pass. That much of unit testing everybody gets, correct? Nobody has any issues with that so far. Okay. So let's have a we'll add this in just for sake of argument. Public void reset. This method doesn't do anything, but let's just pretend it does. So here's the before each and after each. And just intuitively, you might already understand that before and after each runs before and after each test. So and notice now we create the repo once, and we called reset 3 times because we're using a simple singleton pattern here where we're calling get instance, and that's just returning a copy or a reference to repo each time. So each of these methods, it's returning the exact same object, and then we're calling reset on that object 3 times after each one of these tests. Now, does before and after, before each and after each, does that make sense to everybody? We can do this actually here. Let's do it this way. That'll be clear. So the repo is constructed once. We're using this is a naive singleton. It's not thread safe. Well, actually, it's not lazy at least. So it's not a great use, not a great thing to use all the time. But it's good for demonstration purposes here. So when the class is loaded into the class loader, this is instantiated when we get constructed once. Then each time get instance is called on each setup, we get it here, and then after the test, we'll do this. There we go. Sys out. So you type S out and hit enter. It'll type the full system out for you. A little shortcut. Let's run this again, and it'll become even more clear. The repository is constructed. We get instance, button press, we reset. Get instance, get text color, reset. Get instance, get text, reset. Does that make sense to everybody? These are pretty basic concepts, but if you're not used to unit testing, they can catch you up. So I want to make sure we're hammering this home and it makes sense to everybody. This will make even more sense. Okay, so setup, repo constructed. Maybe it is doing it lazy. Interesting. I'll have to look into that. Get instance, button press, tear down, reset, set up. There's the pattern here. Do a setup, do the get the instance, test the method, tear down, that calls reset. Call setup, get the instance again, do the get text test, and then call tear down. Pretty straightforward, but I want to be thorough here so that this makes sense to everyone. All right, so we have our repository, but in this class, it's called MVVM View Model Test. All right, so let's test get text. We'll go ahead and we'll just make a local copy of the view model. All right, here's a local copy of the view model. What is text supposed to be? Let's go look at it. Let's find out. We're supposed to call the repo for it. Okay. Well, how do we know what the repo is going to return? Oh, cancel. Click here. Get text. Text. Now we can even do this. Remember, cert equals, the first one's what's expected, and the second one is what's actual. Let's run it. It passes. Okay, great. We didn't pass in repo into the view model at all. So there's a couple implications to this. And I don't expect you to have ran into them yet. But here's our view model. Here's a single instance of single class of MVVM repo. Well, let's do this. Oops, wrong place. Notice, all I did was put the implements into this class and nothing changed. I can actually now put override here. And it's good practice to do that. Android Studio, I think, will yell at you and make you have to do it. But this little symbol indicates that it's overriding, in this case, an interface. Now, let's think about this. I did this, and why? Why would I make this an interface? I've actually hinted at this before, so somebody might be able to put 2 and 2 together and get maybe 4. Or 11, depends on what math system we're in. Okay. So the reason you would make this an interface is so that you can come and do this. Now, in view model, repo can be new this either. But notice we're still storing the repository there. We store the interface. As long as the methods being called on the repo are part of that interface, we can change out what the concrete implementation is. From network repo, which notice this isn't using a singleton, it's just a regular class, or we can come back to using the original repo. So does that make sense? We're still going along these patterns here. So just let me know if it makes sense what we're doing. It might not make sense why we're doing it yet. Is anybody at that level? Okay, yeah, no, that's fine if you're following and don't feel confident you can replicate it. That's fine for right now. At this point, I'm still demonstrating it to you and trying to work through the logic of why these things are important. Yeah, that's fine. Okay. So here we can change out the implementation of repository, but we come back to our test, we can't, whoops, wrong one. Now we don't have code to change out the implementation of our repository. So that's why having it as a constructor parameter is really useful for testing. Because what you could do this, public void set repo. But notice we made repo final. So you can't have a setter. Well, we could get rid of the final, but maybe we want it to be final. But okay, let's pretend we don't want it to be final. This can lead to some interesting issues in the real world. So we have set repo, come up here, vmodel.set repo. Repo. We run this. Hey, get text doesn't work. But I told it to get text. Why is the repo not giving the view model the right value? Well, it's because if we look carefully, actually, why are we? report. Oh, I see. I did it right. It's interesting to try and code wrong to show up errors, and anyways, the reason why is because this repo is not the one that we just assigned. If we do this, and ran it, now it passes. So this is better. Now we can alter the repository values. This is a step in the right direction. I think everybody would agree about that. Now we can change what repository the view model's using. That may or may not be useful. You may or may not want that. But now at least it's testable. You can change out. And so that's why interfaces are nice rather than just having them hard-coded as single classes. Does that make sense to everyone? If we had repo here as a single class type, then if we wanted to have other implementations of that, what would we have to do? How do you, I can't even use the right term, I'll just use it. How do you, when you inherit from something, how many inheritances can a Java object have? Does anybody remember? Yes, you are both or all right. It is only one. So what if the class you're creating already has a base class, or you want it to inherit from a different base class? Well, then that's why an interface is nice, because you can have unlimited interfaces. And so that's really useful. And did you send an interface object instead of a class object in the parameter? No, I sent a class object. That class object is a class that implements that interface. So you'll notice I'm declaring it as an instance of something. I'm not saying what it is, but it's something that implements this interface, and it's called new repo. And then here, we duplicate this. You could copy new repo here or new repo 2. And they should both work, because they both implement this interface, MVVM repo interface. Now, is this starting to make sense why interfaces are actually useful? Also, notice we click on the interface, we're only defining 3 methods. We don't have to have any actual code there. In later versions of Java, you can have default methods here. I think we touched upon those. It's a little convoluted how those work, and by doing so, you essentially allow pseudo multiple inheritance, but base concept is that it's single inheritance, and then the defaults from interfaces is a little special exception, basically. All right. Well, setting the repo as a parameter might work fine in this instance, but in reality, you generally, if you have something like this that you can toggle, using a setter like this is no problem. However, in a lot of instances, you don't want this to be changeable at runtime. So that's where you would use it as a parameter for the constructor. That's the main difference of why you would use constructor parameters. Plus, if you use it as a constructor parameter, you're requiring that you're making sure that the developer has to provide it. So basically, you're using the syntax against or for, depending on how you look at it, the developer's benefit of writing or using that object. It forces them to do more work up front, but saves them from the possibility of having not set the repository. Does that make sense also? These are things that you're going to slowly gain experience with as you start developing more and programming more. But it's worthwhile to take the time now to sort of explore the rationale behind, well, what's the benefit of doing it this way? Well, why would we do it another way? Trying to wrap your brain around the idea of the underlying concepts of how you test code. Because if you can make testable code, even if your code isn't right, you're much more likely to catch that it's wrong, if that makes sense. Because then you can write tests, and if you see it's wrong, then you can quickly add more and more tests to try and narrow down the root cause of why your logic classes aren't working. Because making UI, even Android, iOS, making UI is not that difficult. It's tedious. Don't get me wrong, it's definitely tedious. And trying to make the UI have the exact right user experience, that can be tedious. But the logic is where you're going to have most of your problems. And so the rationale behind a design pattern like MVVM is to separate out the UI from the logic, even the logic of the UI, so that you can test the logic parts and leave the UI over here in Android land and test in unit tests quickly without importing all of these Android dependencies, which I haven't told you or anything, but Android stuff, when you get it into testing, can get exponentially slower because some of it you have to run on device or do basically shenanigans when it comes to how it's tested. Yes. Somebody said, so basically with tests, you can figure out what's wrong and adjust the code sooner without having to test it a whole bunch of times. Sometimes that is the goal. It's one of those chef's kiss moments when that works. It's not always the truth, not always the case, but generally if you have tests written, it will help you narrow down, or more accurately, it will help you eliminate other sections of your code. So you'll basically have this, we'll just make up numbers, but let's say it's a 1,000-line piece of code. It's this pretty complex stream viewer where you're clicking like buttons and like you're setting a stream up to stream it a video. Okay, great. I'm sorry, I'm having minor PTSD moments there. No, I'm kidding. I actually have worked on files like that. So, you have thousands line code, and you start having tests, and you're testing things, and each one of your tests that work, you can take a chunk of code and mentally remove it from your list of things that need to be tested or checked. So, here's my code works 90%, but this last 10%, there's 3 methods that touch all of those methods that I'm testing. They all have these 3 methods that they all call. Okay, great. You know to investigate those 3 methods. See, maybe you have 3 different errors. Or maybe those 3 methods all call one method that actually has an error. So there's a lot of back and forth. You'll never know for certain, but essentially you're working in your own best interest to try and narrow down the problems. But here's the real trick. Let me click run, and it just ran and it's finished running the tests in 842 milliseconds. Now, if I was to ask you to type in, test the code, but do it all manually, entering values in by hand from the command line, that's a lot slower, obviously. So you can fake inputs here too. You can set them up. You can set up, when you're testing UI stuff, you set click here or click this object. And even automating tests that have to run on a virtual machine, even if you have to do that, those are much slower, but they're repeatable. So you don't have to worry, am I clicking the right spot every time? Am I entering the exact same string? Am I entering the exact same key presses for the dollar amount? All these variables you don't have to worry about. So that's the benefit of unit testing, is speed, repeatability. Those things can help you narrow down where errors are. And one big last one that we haven't talked about yet. Let me think about how to show this. Here we go. Let's duplicate this. Button press. Run this. There we go. Yeah. So I fixed something with button press. I tested button press, but I broke get text. But thankfully I had a test for that. And this is a convoluted example, I know, and realistically it's not a great one. But this is what's called regression testing. I made a change somewhere else, and I broke something. So I know whatever change I just did broke something, so therefore my change isn't good enough. Does that make sense? So let's, it's a good example. Oh, a bank account. A bank account's much clearer. So let's say I have a working bank account instance working, and I'm adding to it interest. And when I add the interest, I accidentally am modifying the balance each day when I'm not supposed to. I'm only supposed to add interest at the end of the month. But I add the interest, and that or it modifies the balance each day. Okay, well, that will show up during other tests, hopefully, if the other tests are designed well, to say, hey, at the end of the day, it started at $100. You took $5 out, you put $5 in. Why do you have $101? That doesn't make any sense. And so hopefully your other tests will alert you that you broke something else new that you were working on. And this is the idea of code accountability, because you would know that your code broke something, so therefore you wouldn't push this to the Git repository or the other source code management system. System died on me again. 1 second. Sorry about that. Need to get the chat back up on the teleprompter. Not sure why that's happening. I'll have to figure that out. But that idea of regularly testing your code and making sure not only did you add the new feature, but making sure you didn't break the old things is useful. Or actually happens more than it should, but you write the code and you actually fixed a bug accidentally, or you realized you fixed a bug and that the test before wasn't testing properly. So in either case, you know that something is I am going this is why technology is wonderful. But no, this is why you test, and you try to test as good as you can. There are, if you saw that article, or maybe it was a video that I linked in general chat, was discussing hot takes, or quote unquote hot takes about development. A lot of times writing unit tests feels to developers as something that is counterproductive and not useful. And so a lot of them don't try to write good unit tests. I have found that I am a big proponent of writing at least basic unit tests for every method. That way you can at least smoke test your code. And if something is horribly wrong, you'll instantly figure it out. This is a cost-benefit analysis of how much effort you put in up front versus the nuance of how difficult it is to get code that works correctly. There is no quote-unquote right answer for how in-depth and amazing and detailed your unit test should be, because mathematically you can't have perfect unit tests of all the possibilities of inputs for a real system. So you always are making trade-offs on, one more variant of this test, or no, I'm not going to. So something to think about, something to know about. The other thing I wanted to talk about, and here's the link. I'll go ahead and link this. This is Kotlin. It's how to make view models with testable states. It's, if you don't know Kotlin, that's fine. I will run through this. Yeah, I'll run through this another time. But I did want to show you for a brief little bit this code here. I really do like this as a sample project. It's how to set up a graph. Here's simple graph of, here's a directed graph. You all remember basic graphs from your math classes. Here's a weighted graph, non-directed. Here's one of the concepts called an adjacency matrix. This is how you would represent the graph in a binary format. So notice A connects to B and B connects to A. So it's a bidirectional line. So therefore they don't bother putting the arrows on either version. But here's a directional graph. A connects to B, but B doesn't connect to A. Does that make sense? I'll just use my phone. Okay. So I'm not asking you to implement this code, because the code is here for you, which that's going to save you a lot of time and hassle. And you'll be able to use this code. And here's algorithms for how depth-first search works. Here's the method for depth-first search. And then breadth first. It's a pretty nice walkthrough of just how graphs work in Java. These graphs are used a lot in more advanced classes, and I think it's worthwhile just to touch upon them. But in this class, we're more worried with advanced object-oriented design, usage, and implementation. So what I'm going to have you all do for your assignment is first, I'll write it up. I'll give out the assignment technically on Thursday, and you'll have a week to do it, and it's pretty straightforward. Figure out some type of binary or text format that you can write graphs to a file and read them and load them into a graph like this. So pretty straightforward. It might take some thought, and we'll see how people are doing next week, and I'll decide on if it needs extended or not. But I think you should be able to do this in a week. It's not that difficult. You're going to have to think ahead, and you might need to do some Googling to figure out how to write objects to a file. Other languages like Pascal have records that are written directly to files, but Java has a couple of different ways of doing it. So I just want to see what solutions you all can come up with. And this is 9 days to work on this. I just wanted to give this to you today, talk about it briefly, and we'll go through there. What I will recommend is, if you notice we talked about interfaces a lot today, I would make, once you make I would define an interface for writing and reading arrays or edges to a file, and then implement your implementation as that interface implementation, or class that implements that interface. It's not required for this assignment, but that will be your next assignment after this one. So if you can do the work once, it might save you some time and hassle. So I think that's about it. We'll go ahead and I'll let you go a little early so you can make it to your next classes, those of you on campus and everything. And we will go from there. If anybody has any questions, I'll go ahead and write up this assignment. I know at least one person is looking for an honors contract summary. I'll go ahead and get that written up and sent out to you. And then if other people are looking for additional work or more in-depth work, I would take a look at this code and implement as many of the software design patterns as you can in this code. And that would be a really good exercise for you if you're looking for more practice, hands-on. So that's actually how I sort of learned, but then also honed and practiced software design patterns myself, is on graphs like this. And then I wrote my own graph library similar to all of this. So that's why I'm partial to this code. But it is nice that it gives you all the code for you. So, all right. I guess we'll go ahead and end here. And if anybody has any questions, you can message me, and then we'll go from there. Everyone have a good evening, and I'll see you again on Thursday. Bye. Y'all come back now.